is fascinating. Oh, hey, geometry. I've got the greatest book I've ever. I can't believe I haven't read this before. All right, let's do some math. We're going to do a quick lesson on 3D figures. If you've got a two-dimensional figure and we want to make that three-dimensional, I'm picking this one because it's probably the only one I can draw halfway. Anyway, you get a cube there. If you have a three-dimensional figure, it's got all straight edges, and it's enclosed like this, that is called a polyhedron. You can have triangular prisms, or pyramids, I mean. You can have prisms. You can have lots of different things. These are all polyhedrons. A sphere would not be a polyhedron because it's got round edges. Anyway, these are called the faces of a polyhedron. These are called the edges, and then these are called the vertexes, or vertices. There are lots of these things, and they give you a lot of them in the book. Bottom of page 76, they show you a lot of them. There are 5 that are kind of historically significant. They're called the Platonic solids. And Plato had this big theory about all of them, that each one represented a different type of basic substance in nature. It was kind of like atomic theory, but it was kind of a little wacko, but it was interesting. Those are on the bottom of page 77. There's the tetrahedron, there's the cube, the octahedron, the dodecahedron, which has got 12 sides, and the icosahedron, which has got 20 equilateral triangle faces. Last thing I think you should know is to figure out how to find surface area. To find surface area of this cube, you're just going to simply take the area of all these 6 faces and add them up. To find the volume, what I think of it as, think of this as being made up of like thousands of pieces of paper or cardboard, something a little more thick. Anyway, to find the volume of this, in other words, the amount of space that it encapsulates, is you're going to take the bottom, the base of this, and I think of it as just being stacked up, stacked up, stacked up. So you want all that stack. So you're going to want the bottom face times this height here. If it was a more unusual looking bottom, it's still going to be the same. It's whatever that bottom is times the height. Okay, that's going to give you volume. Of course, when you do volume, since you're doing length times width times height, you're going to give it to me in units cubed. 3 things are being multiplied together is going to be cubed. Area is going to be squared, and just a plain old distance is going to be just a plain old distance. Okay? All right, I think that's all there is to it. Go back to whatever you were doing.